Today we'll be looking at functions and relations. To begin, we're going to look at what is a function. A function is a special type of relation. A function is a set of ordered pairs. And remember, an ordered pair is always in the form of x, y, which for every value of x, there is only one value of y. So I can't have more than one value of y for every x. So we have two examples here. We have an example of a function and we have an example of not a function. So let's first look at this function here and we can graph it. So let's graph our points 1, 5, 2, 6, 3, 7, and 4, 8. So remember, always start at the origin, go over 1, up 5. We get our point right about here. Our next point is 2, 6, over 2, up 6. Our next point is 3, 7. And our other point, last point, is 4, 8. So you can tell this would just be a linear function because it would form a straight line. The next one that we look at is not a function. So this is an example where a function doesn't exist. So let's graph this. We have 2, 7. So over 2, up 7. We have 3, 8. This will go off the page a little bit at 3, 9. Sorry about that. And 4, 10 would be a little bit higher up here as well. So what you can notice here is that we have the points 3, 8 and 3, 9. But can that exist? No. So why is this not a function? It's not a function because when x equals 3, y equals 8, and 9, which this cannot happen for a function. Now let's look at the next two examples. Are these functions? We know that both of these are relations because if it's a function or not a function, it is still a relation. So both are relations. By definition, we can define what a relation is. A relation is simply a set of ordered pairs. So now let's look at whether these two are functions. So, since we know they both are relations, and any relation can be a function, the first one, we know that for any value of x, there is only one y. So only one y value. So for a is a function. And just so we can write down why it's a function, for each x, there is only one value of y. But what about b? For each x, is there only one value of y? Well, if we look at our relation here, you can tell that there is more than one y value for each function or for each y or x value. So if I look at, say, at 2, for example, there would be 2 y values. So therefore, b is not a function. Now, when we're looking at a graph, a test that we can use is called the vertical line test, where it can help us see if a relation is a function or not. So, if any vertical line passes through more than one point on the graph, the relation is not a function. So just to give you a visual of this, say I had a circle graphed. If we use our vertical line test, we draw a vertical line, and you can see that it passes through 2 points. So therefore, this relation is not a function. So when graphing, it is customary to graph the independent variable along the x-axis and the dependent variable along the y-axis. So what that is stating, it's stating that y is dependent on x. So for example, on distance time graphs, which one is the x-axis? That's right, time. It doesn't change for the distance. So if we talk further about our independent and dependent variables, we can state that the dependent variable is said to be a function of the independent variable. Therefore, distance, for our above example, depends on time. Such as 10 kilometers per hour. So you notice that your distance depends on your time. So 10 kilometers depends on your hour. So now we'll continue looking at something that we have looked at in our previous unit, which we touched upon but didn't really do too much information on. So let's look at our domain and range. So when talking about domain and range, we can look at the set of first elements in a relation. So the first set of elements in a relation, which we normally call X, is called the domain. Whereas the second set of elements in the relation is called the range, which we often specify as Y. So for this relation, 1, 2, 3, 4, 5, 6, 7, 8, what is our domain and what is our range? So remember, our domain is always going to be the set of first elements, which are our x's. So looking at this relation here, we're going to look at each x value. So 1, 3, 5, 7. So that is our domain. Whereas for our range, you're always going to look at your y values. So we have 2, 4, 6, 8. So a function is defined as a set of ordered pairs, which for each element in the domain, there is exactly one element in the range. So what that's saying, again, is that for every x, there is only one y. So looking at this example here, negative 2, 2, negative 3, 3, negative 4, 4, negative 3, 5, and negative 1, 6. Is this relation a function? Well, let's look. So when we look at this, you see you have your first x value here of negative 2. Are there any negative 2 x values? So your domain? No. What about negative 3? We look, yes, there is another negative 3. Now look at your range, your y values. Looking at your y values, we have a 3 and we have a 5. So therefore, this isn't a function. So therefore, this is not a function. Okay, when x is negative 3, y is 3 and 5. Now we will begin looking at function notation. Now function notation is something that you guys have seen previously, but we're going to look at it in a little bit more depth. Now to begin, in a function such as y equals 2x plus 3, y depends on x. And is a function of x. So, an equation that is a function, okay, note that it needs to be a function, can be named using function notation. So, our notation that we are commonly used to working with is our xy notation. Now, when looking at our function notation, what we're going to do is instead of saying y equals 2x plus 3, we are going to say f at x equals 2x plus 3. So the symbol f at x is the value of the function f at x. So it's saying that this whole function is equal to such a value at this specific x value. It is also stated as value of f at x. So when looking at this, to find f at 5 for a function, f at x equals 2x plus 5, what we're going to do is you're going to first sub 5 in for x. So we then sub 5 in. So all we do is replace our x value with our 5. So you have 2 times 5, which is 10, plus 3 is equal to 13. Now one thing that I want you to please note here is that often we see this happen, is that the left side is not part of the equation. So what I mean by that, I don't want anyone seeing or writing that 5f is equal to 10 plus 3 and then f is equal to 13 over 5. This is incorrect. So please, no one do anything like this. Always sub in for your x value. So f at 5 is equal to 2 times 5 plus 3, which is equal to 10 plus 3, which equals 13. Now I would like you to pause the video and work on these 3 examples. So example 1, is this a function? So I'd like you to copy down the examples and complete them. Once you've completed them, that is the end of the lesson. Please call me over and we can discuss. And example 2, state the domain and range of the following relation, and then state whether it is a function or not. And in example 3, I want you to write the following in function notation and then find f at -2.